In this video, we're going to talk about how to find the expected value, variance, and standard deviation of a discrete random variable. This lesson aligns with the Common Core Standard in Mathematics S-MD.1 for statistics and probability. We will be using both longhand methods and technology Let's consider the following problem. Suppose you pay $5 to play a card game. In the game, a card is drawn randomly from a standard deck of 52 cards. If you draw a red card, you win nothing. If you draw a spade, you win $5. If you draw a club, you win $10, plus an additional $10 for the ace of clubs. Find the expected value, variance, and standard deviation for this game. We're going to begin by drawing a chart with 3 rows and 5 columns. The first row should contain the label for each category, and the second row should contain all possibilities for amounts won or lost. Those are our x values, or our random variables. The bottom row should contain the corresponding probabilities, that is, our p of x values. So here's what your table would look like. There are 2 things that are very important which I'd like to point out. The first is you'll notice, if you look at the column for red, that we have -5 in the x row. This is because if you draw a red card, you win nothing, but you paid $5 to play, so you have to account for that $5 loss. As we continue along the row for the x values, you'll notice that the winnings have $5 subtracted from each one. So for example, if you win $5, you're really breaking even. So if you draw a spade, your x value is equal to 0. The other important thing that I'd like you to notice is that our probability values are not represented as reduced fractions. We're going to begin by working this problem out longhand, and then we'll go back and repeat the problem, this time using a TI-84 graphing calculator. The formula for finding the expected value of a discrete random variable is the sum of x times p of x. So in other words, we take each x value, multiply it by its corresponding probability, and then sum the products. So we have -5 times 26/52 which equals -130/52. And here, at this point in the process, it is okay to reduce our fractions. This one can be reduced to -5/2. Next, we take 0 times 13/52, multiplying the x times p of x for spades. And of course, this gives us 0. Then we have 5 times 12/52. This gives us 60/52. which reduces to 15 over 13. And lastly, we have 10 times 1 over 52, which gives us 10 over 52, and reduces to 5 over 26. Now we take the sum of each product that we found, and I would do this using a calculator because you'll be expressing your result in decimal form most of the time when you're working expected value problems. When I add these together, my result is negative 1.15. So in other words, the expected value to play this game is negative $1.15. Do you think this game is worth playing? Probably not. Now that we have found the expected value, we are going to find the variance. The variance is also denoted as sigma squared, or you may see it written as variance of x. And the formula to find it is the sum of x minus the mean squared times the probability of x. So in other words, for each x, we're going to take it, subtract the mean from it, square the result, and multiply by the corresponding probability. Here, the mean is our expected value, negative 1.15. So let's get started. Our first x is negative 5, so we take negative 5 minus negative 1.15, square the result, and multiply it by the corresponding probability, which is 26 divided by 52. And as we work these out, we'll use the decimal approximations for the answers. So we have 7.41125. I usually don't round very much when I'm working on expected value problems until I get to the end. For our next random variable 0, we have 0 minus negative 1.15 squared times the corresponding probability, which is 13 over 52. This gives us 0.330625. Our next random variable is 5, so we have 5 minus negative 1.15 squared times the corresponding probability, which is 12 over 52. This gives us a result of 0.25. And finally, we have 10 minus negative 1.15 squared times 1 over 52. And let me go back here to this step. I noticed that I mistyped a key in the calculator, so I'd like to just rework that. We have 5 minus negative 1.15 squared times 12 over 52. And this is equal to 8.6 728,269. Finally, we have 10 minus negative 1.15 squared times 1 over 52 which gives us 2.390817. If we take the sum of each of these values, our variance is 18.860961. So here we have our expected value, our variance, which from the last screen I've taken and rounded to 2 decimal places, the hundredths place. And lastly, we need to find our standard deviation. Fortunately for us, we've done most of the work, and the standard deviation is simply the square root of the variance. So, all that's left is to take the square root of 18.86, and we find that our standard deviation is approximately 4.34. Now let's talk about how to find your expected value, variance, and standard deviation on a graphing calculator. You're going to start by pressing the Stat key, then press Edit, which is number 1 on your Stat menu. Put your X values into L1, that's your list 1. Put your P of X values into L2. Your L1 and L2 screens should look like this. Next, you're going to press Stat, Calc, Option 1, which is 1 variable statistics. And for list, in that field you should have L1. In your frequency list, you should have it set to L2. You can set them by hitting the second key and then the 1 key for L1, or second, 2 for L2. Then press Enter, and here are the results. We have our X bar, which is our expected value. You can see that's negative 1.15. We don't have our variance, but we do have our standard deviation, sigma x, 4.34. And to find the variance, you'll simply take sigma x and square it, which will yield the 18.86, which we found earlier. So this concludes our example of finding the expected value, variance, and standard deviation of a discrete random variable using longhand and technology. I hope you found it helpful, and we'll see you next time.